right, now let's talk about a really slick mathematical tool called sigma notation. Okay, go ahead and write this down. Definitions, you know they tend to show up on tests and quizzes. The sigma, let me just go ahead and explain it first. The sum of the first n terms, a1 plus a2 plus a3 plus dot 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 plus an, can be written in shorthand form, and that's called the summation I equals 1 to n of a sub I, where I is the index of summation, ai is the ith term, so ai would be in here. The upper and lower bounds are n and 1. Now this is a Greek letter, and a lot of times I'll just write it like that, capital sigma, and it always means add them up. That literally is what it means, add them up. Okay, that's not the actual scientific term, but that works, all right? So whenever you see this, you know you're going to add up a bunch of things. All right, so if I want to add up the summation, I equals 1 to 6 of I, what would that be? Well, everywhere I have an I, I'm going to just quite literally add them up. So for this, it would be from I equals 1 to 6 would be 1. Okay, now I'm going to tick that off. I is going to become 2. Plus, now I'm going to replace 2 in where I is, so that's 2. Plus, all right, I'm going to tick that one off. 3. So everywhere I have an I, I'm going to replace it with a 3. Plus, tick that one off. 4. You kind of getting the idea? Okay, tick that one off. 5 plus 6. And you stop when you reach the top number. Now let's see how we'll do this one. This one we're going to start at 0. We don't always have to start at 1. So the first thing we're going to do is everywhere we have an I, I'm going to put in a 0. So this is 1 plus, now I'm going to change it to 1. And you don't have to do this, all right? I'm just showing you how the logic here. So everywhere I have an I, I'm going to put a 1. So this is 1 plus 1. Plus, now I'm going to change it to 2. 2 plus 1. Plus 3 plus 1. Plus 4 plus 1. Plus 5 plus 1. Now if I asked you to expand these terms, you don't have to put all this in here. You could put 1 plus 2 plus 3 plus 4 plus 5 plus 6. That's perfectly fine. Now you kind of have the idea, so let me do this one in one step. I'm going to start at 3, so this is going to be 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared. Boom, we're done. Okay, now this one's kind of confusing because this one's got some junk in it. I've got n's down here. What do I do when I have n's there? You leave them because we are my index here is k, not n. So this will become 1 over n times 1 squared plus 1 is 2 plus 1 over n times 2 squared plus 1. I'm going to go and write these out. Plus 1 over n times 3 squared plus 1. Now, where do I end? And the answer is, well, you can't write out all n because you don't know what n is. So you're going to put plus and then 3 dots. I know that looks like 4, but it really is 3. 1, 2, 3 dots. Plus, and then you're going to write in your last term, your nth term. 1 over n. Now, wherever I have k, I'm going to put in n. So this is n squared plus 1. All right. Now, you're going to get to where you really love this one. For this one, this is f x1 delta x. Everywhere I have an I, I'm going to count off from 1 to n. Plus f of x2 delta x. Plus f of x3 delta x. Usually 3 is enough to give you an idea of where you're going. 3 dots plus, and then you're going to put in your nth term, your last term. F x of n delta x. Now, a lot of times we use different indexes besides n. Sometimes we use i's, sometimes we use j's, sometimes we use k's. Don't let that throw you. Just remember, whatever is down here, okay, whatever we're counting with, we're going to replace, we're going to count up one at a time, and we're going to replace whatever is in our formula or equation here with those different k's. So here we didn't change our n's, we changed our k's. Now, memorize this. You're going to need to know these. Oh, I don't know, test or quiz next time? Yep. If I add up the summation from I equals 1 to n of c, that gives me just Cn. Now, c is just a constant, so think about this. Suppose I have some c out there, and I have c plus c plus c plus dot 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 plus c, where I have n of these. This is going to be c times n. That one was easy. I won't prove all of the other ones. They're a lot of fun to do. What if I sum up from I equals 1 to n of I? That sum is n times n plus 1 over 2. So if I were to sum up I equals 1 to, say, 10 of I, that's going to be, my n is 10, so it's 10 times 10 plus 1 divided by 2. So that's 5 times 11, or 55. Do you see how easy that is? There's a really cool, slick thing we'll do in class where I show you how to figure that one out. For the third one, the sum of I squared is n times n plus 1 times 2n plus 1 over 6. So the sum from I equals 1 to, say, 10 of I squared. So now we're adding 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. This is 10 times 11, now 2n, so that's 10, 21, divided by 6. Not so easy. So that's 7, that's 5. So you get, what, 77 times 5, or 385. Now, you see how much easier this is than adding up 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared plus 6 squared plus 7 squared plus 8 squared plus 9 squared plus 10 squared. I mean, we'll do this in class, and you're not going to like it. This is much easier. Now, the summation, I equals 1 to n of I cubed, is n squared times n plus 1 squared divided by 4. Just memorize this. Suppose I want to sum I equals 1 to, let's just do 5. Let's go on and do 10. We've been doing 10, so that's okay. I cubed, well, this is 10 squared times 10 plus 1 squared divided by 4. So this is 100 times 11 squared, which is 121, divided by 4. So 121 times 100 divided by 4 is a really big number, 3025. All right, you give them a go. Stop the video when you're done. Finish your homework.